Okay, in this video, we're going to talk about reciprocals, and we're going to connect these concepts to what we just learned in the previous video, and that's going to help us in bending our straight line to fit our data, which is y equals 1 and y equals 0. Let's look at reciprocals. I'm sure you're aware of this topic, but I want to talk about it a little bit to give you some very important intuitive understanding about reciprocals. So reciprocal is nothing but 1 divided by a number, and the reciprocal of 1 is obviously 1. The reciprocal of 2 is half, and similarly the reciprocal of half is 2. Similarly, the reciprocal of 0 is 1 divided by 0, which is infinity, and the reciprocal of this is 0. Also, note that the reciprocal of 1 is 1, and the reciprocal of any number which is greater than 1 is always less than 1. And similarly, the reciprocal of any number which is less than 1 is always greater than 1. So the reciprocal of 0, which is less than 1, is infinity, and the reciprocal of infinity, which is greater than 1, is 0. And you also note that as we approach 0, the reciprocal approaches infinity, and as we approach infinity, the reciprocal approaches 0. And so it's kind of flipping the space between 1 and 0 to 1 and infinity. And similarly, reciprocal is almost like flipping the space between 1 and infinity to 1 and 0. So to help you visualize this a little better, I have this kind of a representation here where this is the x-axis and this is y equals 1, and for these 2 points the reciprocals are going to be here, and for these 2 points the reciprocals are going to be here. Specifically for this point, the reciprocal is going to be here because this point is closer to 1, so the reciprocal is also going to be closer to 1. Well, this point is closer to infinity, not really, but it's further away from 1, so the reciprocal is going to be further away from 1, closer to 0 actually. And similarly, the vice versa logic also applies. The reciprocal of this point is going to be above 1 and close to 1, because this point is also close to 1, and the reciprocal of this one is going to be above 1 but away from 1, because this point is away from 1 and closer to 0, so this is going to be closer to infinity. So just keep that in mind, and with that we're going to talk about reciprocal of the right side of our bent line. Okay, so we want to find the reciprocal of this part of the bent line. So you from the previous video, you probably remember that this point is at y equals half. So the reciprocal of this point is going to be at y equals 2. And since these points are going to approach close to 1, the reciprocals of all of these points are going to approach close to 0. So the reciprocal of this entire line is going to look something like this, and it starts from y equals 2 and goes downwards towards 1. So this is how the reciprocal is going to look for this part of the line. Also, reciprocal of the reciprocal is the same thing, right? So reciprocal of this is this, and the reciprocal of that should be this, right? Because that's by definition of reciprocals. So keep that in mind that what we have found as a reciprocal has its reciprocal as this. Now let's look at the left half of the bent line. Since this is starting from half, the reciprocal of this point is going to be 2, and since this is going towards 0, the reciprocals of all of these points is going to be approaching infinity. So the reciprocal of this entire thing is going to start from 2 and going to approach infinity. So to help you visualize, I have drawn this, the left part of the bent line and the reciprocal approaching infinity. Now if you combine by the way, the reciprocal of this is obviously this, because it's the reciprocal of the reciprocal. Now if you combine these left and right sides and put it together, then the reciprocal of this entire bent line is this nice smooth looking curve here. And the reciprocal of this nice smooth looking curve is our bent line. So if we are able to come up with this curve and find its reciprocal, then we'll come up with the bent line. So somehow we have to get to this. So if you remember, this all started because we wanted to convert a straight line to this bent line. So now we want to convert that straight line to this curve, and then this curve can be just reciprocated to get this bent line. Now what I'm going to do is just focus on this, because this is now important for us. And if I have to focus on this, I'm going to ignore this part, and for that I'm going to basically call this as my x-axis and kind of ignore this part, and just recollect that this point is y equals 2. So if this becomes my x-axis, then this point becomes y equals 1. So let us look at how that looks. So this is my x-axis and this point is y equals 1, and this is that curve. And since this is y equals 1, I'm going to do the trick again. So I'm going to draw y equals 1 here, and I'm going to try to find the reciprocal of this along this point now, along y equals 1. So if I have to find the reciprocal of this, I'm going to do the same thing again as I did in the previous case. I'm going to find the reciprocal of this point. Now here, since it's 1, the reciprocal of this point is going to be 1. And since all of these points are going above 1, closer to infinity, the reciprocals of all of those points is going to be going down closer to 0. Similarly, since the points on the right side of y-axis are going to go closer to 0, the reciprocals of all of those points are going to be going away from 0 towards infinity. So the reciprocal of this entire line is going to look something like that. So let's see how that looks. That's exactly how it looks. And also remember that if I find the reciprocal of this, I'm going to come up with that same line again. So to make it very clear visually, we had this line before. Basically it's a curve, not a line. If we have this curve, then the reciprocal of this curve is going to be this curve, and the reciprocal of this curve is going to be this curve back. Now if you look carefully at this, there's kind of a visual reflection along y-axis, and that is very true. This line is, this curve is kind of visually a reflection of this curve. In other words, if we are flipping the x-axis, then this curve becomes this curve. So in other words, if we are flipping the x-axis, we get the reciprocal of this curve, right? We also get the reciprocal of this curve, which is this. So when we flip the x-axis, we are actually just getting the reciprocal of our curve. And this is very important because if you remember, our bent line, which we want to finally find, is kind of anti-symmetric around y-axis. And this is a very important property that this curve should possess, which is reflection along y-axis, if that anti-symmetry in the bent line has to be maintained. So since this is kind of anti-symmetric of this has to be a reflection along y-axis. Now if you think that you're confused at this point, just rewind the video a little bit and watch it again, because it's very important to understand why this is a reflection of this, especially in terms of the fact that the bent line that we finally want has to be anti-symmetric along y-axis. That is the reason why we want this part to be a reflection of this part. So just keep this in mind, and we're going to stop the video here. Keep in mind that when we are flipping the x-axis, we are actually getting the reciprocal of this curve. So with that thought, I'm going to move on to the next video, where we'll talk about how this property of flipping x-axis leading to reciprocal is going to be used to get this curve.